My name is Angela McLean. I'm here to chair this session, and I'm not a botanist and I'm not a seed banker. I am, however, an absolutely enormous fan of Kew Gardens. So Kew is the, thank you, you just keep telling me. Kew is the organisation that runs the seed bank that you were just seeing something about there. And I'm very much hoping that Alex, the Director of Science at Kew, is going to tell us some of what goes on there. My job is the Government Chief Scientific Advisor for the United Kingdom. So what I'm tasked with doing is making sure that the UK government has excellent science advice available when it's making decisions, and that's made much easier for me because we have fabulous science organisations like Kew and of course like others around the world to gather that science up for us. I'm a deliverer, but I can't generate all the science, obviously, that I need to try to get to the right place at the right time. So I think really what I'd like to do now is to invite Alex and Ashmahani up to the stage to come join me. What we're going to do is start off with just two panellists, and then we're going to invite, you can see we're going to invite some more panellists to the stage, but let's start. Please, join me here. So I wanted to start by asking you to give us some framing, opening comments around this topic. Shmahani, may I begin with you?
Sure. So, open your remarks. So we don't hear each other. You can hear us, but we don't. So thank you so much, Angela, and congratulations to the Millennium Seed Bank on its 25th anniversary. Let me start by really thanking the UK government for the support to the CGR and the continuous, really great partnership, and the latest announcement that we got 2 days ago of £76 million over 4 years. So we are really grateful to the UK government and to the population of England for really supporting the CGR. So the CGR gene banks conserve unique crop diversity on behalf of the international community. They give users resources to respond to almost any conceivable challenge related to agriculture. Located in a diversity hotspot on 5 continents, they hold over 700,000 accessions of over 3,000 plant species. And this includes traditional varieties and wild species, many of which can no longer be found in the fields or the wildlife. If it hadn't been collected and preserved in these centers, much of this diversity would already have been lost. In just the last 3 years, the Gene Bank have distributed well over 300,000 samples to users in 124 countries. Along with CGR breeding programs, our gene bank accounts for nearly 90% of germplasm exchanged internationally under the Plant Treaty of Plant Genetic Resources. Thanks to the work of the germplasm health units, also known as seed doctors, these materials cross borders without the risk of spreading pests and diseases. The work of these units is vital to all of CGR programs. Without them, the global system of sharing plant material couldn't function. So conserving crop diversity safely and making it available is one of CGR core raison d'être and core responsibilities. It required skilled personnel, reliable funding, and a robust policy framework. But we should and must do much more. In some cases, gene banks' resources aren't being intensively used due to a lack of capacity or awareness on the part of the national partners. We want to do more to address this. and the emergence of new technologies, for example, in the field of AI and genomics, means we can provide much more detailed, targeted information to users ensuring they find the resources they need. Our goal is not just to conserve precious crop diversity and to provide free access to it, but also to ensure that the communities on the front lines of the food and climate crisis benefit fully from these resources. There is enormous potential to enable smarter, more widespread use of crop diversity underpinned by sustainable conservation and supportive policy environment and exceptional phytosanitary controls. The need for genetic variation in agriculture has never been greater, but the tools at our disposal are more powerful than ever before. Gene banks can make our agriculture more sustainable, resilient, and productive through diversification and biodiversity. Today's session is a chance to explore how we seize that opportunity. I'm really looking forward to the discussion, and I'm looking forward really to tell you more about the genetic resources that we have in our gene bank and get you to be curious enough to come and visit us, be it in Colombia, Cali, or in Mexico, or in Rabat, or in Philippines, or India, or other places of the world. Thank you so much.
Thank you so much, Ismahani. Alex, may I turn to you for your suggestions about why do seed banks matter and what we need to discuss about them?
Sure, and it's such a pleasure to be here. I'm Brazilian, to welcome you all here to my beautiful country. And I've been in this role at Q for nearly 7 years. And I do want to say that the seed bank is something that we're most proud about. And the fact that we are now this year celebrating 25 years is very special. Can I just have a show of hands? How many of you have been to Kew Gardens in the UK? Most of you. And how many of you have been to Wakehurst, where we have a seed bank? Just perhaps 1/4 of those. And please do note that we are not only one garden, we are distributed in 2 places. And Wakehurst is where we have the Millennium Seed Bank, which is the world's largest and most important effort to conserve wild plant species, which is really highly complementary to the work of conserving crops for our sustainability and food security. So we're now celebrating this amazing feat of banking more than 2.5 billion seeds from more than 40,000 different species, which is incredible. So over 25 years, thanks to the great partnerships we've had in almost 100 countries, we've been able to bank a large proportion of the species from nature, but also focus in those 3 E's, which are the economically important ones, the endemic or narrowly distributed, and those that are endangered or threatened. And we know from our work at Kew that about 45% of all plants, flowering plants, are threatened, and they're likely to go extinct in the coming decades unless we do something about that. And therefore, the seed bank has been an incredible extra insurance, and we already know that we have species there which are no longer existent in nature. So that's really why this has been so important up to now.
Fantastic. Thank you very much for those introductions, both of you. So let me ask you the very obvious question. Why are we talking about seed banks here at COP?
So I think if we look at COP, so what's one of the major issues we have globally? It's climate change. So climate change impact, it's seen from different people in different ways, but what is sure, there is a heat, the planet is heating up, so we'll have much more temperature. There is also a movement of insects and diseases. There is variability, which is the most important and maybe the most disruption in terms of agriculture, so floods, droughts, and different variability. So all of this means that you need to breed crops that will be better for the new scenarios. And that's where seed banks are very important. So seed banks basically brings the history of, if we talk about plant evolution, plant domesticated throughout millions of years. So the fact that we have them, it's to use them. Now, it's not only to make sure that we preserve them, but also that we use them as we are breeding for tomorrow's environment and scenarios. So I think we can't do it without the seed banks. It's almost impossible, so that will allow us to adapt to climate change, but also it will help us to mitigate it. So if you want to really increase sequestration capacity of any of your cropping systems, the gene banks can allow you to find those genes and those species. If we talk about resilience, be it in communities, be it in farming systems, again, you need to go back to those seed banks and look and fetch those genes. The difference in the past and now is that, again, the technologies. So we have been conserving gene banks for a very long time, seeds and species. Have we been using it enough? No, definitely not. We are hardly using a very small percentage of the whole variation that we have. And that's where new technologies are crucial to allow us really to mine those wonderful diversification to find the genes that we are looking for, be it heat tolerance, salinity tolerance, disease resistance, and so on and so forth.
Fantastic. And Alex, can you give me examples either of where we've used seeds in seed banks to solve a problem in climate change or adaptation or loss of biodiversity, or an example of where new technologies are helping us do better?
Sure. So yes, I think seed banks have already demonstrated their value for tackling those big questions, because with climate change, as the weather gets hotter and more unreliable, there are two things you can do. The first one is, of course, to fight back or combat, so mitigation, right? And that's where we know that nature-based solutions can contribute to about a third of all the climate mitigation challenge. And I think here, the United Nations has declared this to be the decade on ecosystem restoration. And restoration, the biggest bottleneck for that is seed supply. So we have been able to, for instance, help our partners in Australia after the terrible wildfires that happened some years ago to send back some of those seeds of really threatened species. So basically, tackling the biodiversity loss which took place because of fires, but also to restore habitats which then captured carbon. And the other part of fighting climate change is about adaptation, as you said, Angela, and that's really about finding alternatives to some of the crops. And I think there's some really good examples where our seed banks have been used for increasing the genetic diversity in some of the crops. And there, I think the distinction between crops and wild species is becoming increasingly blurred. And that's why I think the collaboration between our organizations is so important moving forward as well.
Examples of moving genes from wild species into crops?
So, I mean, just one example is around coffee, and some of you will be aware of the work we've been doing at Q in terms of coffee resilience, and you love your coffee here. Nearly all coffee you'll get are from two species, the Robusta or Arabica coffee, and here we realized some time ago that it's becoming increasingly impossible to transfer genes or to do gene editing, which will make coffee more resilient to climate change. And both coffee varieties are very sensitive to drought and heat, which means that across the world, every tropical country which grows coffee today is struggling, right? So what we've been doing is to look back into our collections, both in the seed bank and in our herbaria, and locate species and varieties which have been consumed up until about 100 years ago. And it turns out that there are more than 120 different species of coffee, and some of them have traits which are really much more adaptable to a warmer climate than the traditional varieties. So I think this is a good example where our collections from the genes that we have in our dried specimen material, but also in the seed bank, is helping us come up with complementary approaches to tackling food insecurity, and that includes, for instance, coffee.
Thank you. That's a great example, close to all our hearts. So you're going to come up with another one?
Yeah, I could talk about the false armyworm. That was a disaster in 2022. And if it wasn't really for varieties that are tolerant, not resistant, but rather tolerant to false armyworm, it would have spread all over Africa. So it's a very nasty worm that affects many species, not only corn, but also wheat and other. So it was very important to really mine in the gene bank to find those genes. The other example I could bring, it's also low glycemic rice, for example. And we have our center in Philippines, IRI, that works on low glycemic index in rice, but also in Africa rice and also in SIAT. We have our colleague with us here in the Alliance see at Biodiversity. So those genes of low glycemic index were found by screening the genetic material and finding those genes. And just to give an example, Erie in the last 2 years scanned about 60,000 accession of rice in only 2 years, which it seems it's much more than what they screened in the last 52 years. And it's because of technology like AI and photography and other criteria that we can use to get to certain genes.
So can I explore that a little bit? You've spoken several times about the role of new technologies in speeding up and deepening this work. How does photography help?
What?
You mentioned that photography was one of the technologies you were using to do this work much more quickly. How does that help?
So basically, in the old days, if you are looking for a certain genotype or a certain phenotype, what you need to do is take your species and plant them. And if it's a disease, you have to affect them with your fungi or insect and see which one is resistant. With the AI, for example, in the low glycemic index or in for example, certain antioxidant, what we are using, it's a model. So you're using a model that will help you identify which one might have that gene. And you are using photography in this case, whereby you are looking at certain shapes and certain colors that you have indication that it means you have that gene. And that really reduce the number of plants or species or accession, really not species, accession that you need to plant in the field. So it really reduce in terms of how many species you need to take through the cycle in the field to see that certain phenotype. Of course, it's not accurate 100%, but it's really reduced the cost. The other example that I should really mention on really beautiful discoveries from GeneBank, it's high iron potato. So as you know, anemia is a huge problem in many, many countries. And in Peruvian highland, women eat about ½ kilo per day of potatoes because they don't have much else to eat, but they have huge anemia. So the scientists look into the gene bank of the potato and find one species that has almost 3 to 4 times more iron. And in the potato, the bioavailability of iron is huge. It's not like many other crops. So right now, we have a variety of potato that is under scaling up, particularly in Peru, because basically a woman, if they continue to eat ½ kilo of that potatoes, they have about 2/3 of their need in iron. And that came from the gene bank again, and very targeted research.
That's a glorious example. Alex, same question back to you. So thinking about exciting new uses of technology that you've seen being used in seed banks.
Yeah, so I think one thing that is really exciting, but also very challenging, is the need for cryopreservation. And the problem, in a sense, is that for 25 years we've been doing the easy seeds first, and we've been adding, seeds from species which are easily bankable, and try to kind of avoid those that are more difficult. But we know that, especially in tropical areas, and if you think of plants like avocados and oaks, those seeds are incredibly hard to bank. And therefore you need some really high-tech methodologies which are often unique to each particular species. You have to remove the different parts of the coat, you need to work with the embryo, and you need to use liquid nitrogen. So those technologies are now allowing us to preserve those seeds, which have been very challenging so far. But it also requires us to work with a lot of new technologies to see how those seeds are doing over time. So we cannot wait 20 years to see whether they've survived. So we have to accelerate aging in different controlled ways so that we can really learn how to use the best possible protocols for that. So I think by using X-rays, which we're doing now, and increasingly so with machine learning, we can predict the success of both storage and germination, so that we only focus on the manual propagation and germination of those seeds that we are most unsure about. And therefore, I think there's some really good advantages of making this more cost-effective, but that requires us working with new technologies, including for cryopreservation.
And sticking on that theme about looking to the future, what do you see as the biggest challenges to running a really useful seed bank looking forward?
Yeah, it is really exciting time now because we are now in very deep discussions with our partners around the world about where can we really add value to the challenge they're facing today. And I think here it is mostly about coordination, I would say, and about resources. So we know that we need a distributed approach so that seed banks around the world can work together collectively to crack the nut or really understand how, for instance, to best tackle those recalcitrant, the difficult species or exceptional species which have been very challenging so far. When we started 25 years ago as a wild seed bank, we're almost alone. And now there are hundreds of different infrastructures around the world which all have resources in terms of knowledge, but also, of course, the seed banks. And collectively, we need to have that kind of global coordination moving forward. So I would say coordination and I think resources, of course, to be able to bank those not only species, but the populations within species so that we can increase the genetic diversity within those species as well. And that will help us both tackle biodiversity loss, but also doing some very practical experiments and approaches to use those seeds for whatever humankind needs in terms of diseases, in terms of food insecurity, in terms of new source of fibers and micronutrients, for instance.
And I'd like to ask the same question to you, Ishmahani. What else do you see as the real challenges in the future for seed banking?
I think I'll focus on the funding. So we have been unable really to attract enough funding to protect what we have. And not only we need to protect what we have, but we need also to expand collections. When was the last time we have been collecting species from different parts of the world? So there is a huge need for both collections, particularly in areas where we haven't collected, particularly in Africa. There is a huge need to maintain really what we have for a longer term. So you need facilities that can take it over centuries, not only years. And we need also to expand it from only plant to animal, to fungi, to bacteria, to viruses. So it doesn't mean if we don't see them that they don't exist. So most of the soils, and we have a soil bank in ICRAF, but it's very simple. It's not really at the state that it needs. So I think really in terms of biodiversity, we need more conservation. We need more investment in understanding it because that's the future. So we need to understand nature, and the only way to understand it is understand those multiple species and understand the synergies that happens in nature. So for all of this, we need young people that are passionate about the subject, and I'm not sure we do have enough of them. And we need more funding to be able to do all of that.
Fantastic. Thank you both so much for kicking us off to this absolutely fascinating start in this topic. I'd now actually like to invite our other panelists to join me here on the stage. Marcela Quintero has very patiently sat here. Marcela is the Associate Director General for Research Strategy. Now I'm going to ask you two, we're just going to have to share microphones, I think.
So should we?
No, Angela? No, you stay. Sorry. Marcela is the Associate Director General for Research Strategy and Innovation at the Alliance of Biodiversity International and SIAT. Is that how you say it? Thank you, Marcela. Welcome.
Thank you.
I'd also like to invite to the stage Tek Sapkota, who's the Principal Scientist. Hi, Tek. Please join us. Tek is the Principal Scientist at the International Maize and Wheat Improvement Centre. And I would also like to welcome Biren Hooper, who's the Assistant Director of First Nations, Nature and Inclusion at the Department of Climate Change, Energy, the Environment and Energy from the Australian Government. Have you got a microphone down there? So I suggest we do one between two.
Okay. Okay. So, hello everyone, I'm Marcela Quintero. Whoa. I work for the Alliance of Biodiversity International and SIAT. We are two research centers that came together, came together 5 years ago but built on a trajectory of 50 years. So that's why we call ourselves the Alliance of Biodiversity and SEAT. I'm the research director there. And I'm here today because we host also a mandate as other CIR centers to conserve agrobiodiversity. So we have a large seed bank in Colombia, here in South America, another one in Europe that has the largest collection of banana. And I just wanted to say that it's not only about the conserving the agrobiodiversity, the mandate we have, but also to use that agrobiodiversity. So I'm going to stop here and then allow the others to introduce themselves.
Marcella, thank you. If I could turn to Tech, could you introduce yourself and the work that you're doing, please?
Thank you. Hello, everyone. This is the technique, right? My name is Tek Sapkota. I'm a principal scientist at Summit, which is International Maize and Wheat Improvement Center based out of Mexico City. And in Summit, it is mainly wheat and maize-based cropping system, but we work across the cropping system and farming system. Although when it comes to seed and seed bank, it is all about maize and wheat and dryland crop seed. So I'll come up with the work that we do, but I'll let my colleague to introduce, and then I'll come back with the work that we do at Summit.
Lovely, Tech, thank you. Please, yes. Biren, would you introduce yourself and your institution's work?
Hello, my name is Biren Hooper. I'm here as part of the Australian government, I guess a recipient of the work of the Q to help us to conserve our seed banks, and very happy to be here on the celebration of 25 years of the Millennium Seed Bank Partnership and the work that the Q does. So I'm a assistant director in the First Nations, nature and gender space in the international climate negotiations. This is a bit of work that the Australian government has recognised that kind of Indigenous sciences and nature need to be reflected better in the work of the UNFCCC, and it's our way forward with that. Yeah, I'll leave it there. Thank you.
Thank you all so much for those introductions. Marcella, can I start with you? I think I'm right in thinking that SEAT is focused on Latin America. Talk to me about why seed banking is so important for your part of the world.
No, thank you. So we work across the three regions, Asia, Africa, and Latin America. We have our main research campus in Colombia, but from there we do research for the world. So it's not only for Latin America. And why is important the work that we are doing in terms of conserving the agrobiodiversity, but also using it, as I was saying. So we have the largest collections of beans in the world. That's part of our mandate. Also of forages, and also cassava and banana. So we have, it's important in the sense that it's not we only are safeguarding that agrobiodiversity, but also we have to provide that agrobiodiversity and make it available to whoever wants to use it. So that's why it's important. But the other part is that we deploy science to characterize what traits we have in those beans, on those bananas, on those cassava that can serve the needs that we currently have in the world. So we are not talking only about producing more and then trying to breed better beans to produce more beans, but also to develop beans that are drought tolerant. Or, for example, we are now exploring all the collection that we have of forages to see if we can find a diversity of forages that have antimethanogenic compounds, meaning that forages that can help to reduce methane emissions from enteric fermentation. So that's why it's very important, because we can see it on a lot of agrobiodiversity that we have in the seed banks, but what is mostly important is that we have the breeding programs that allow us to characterize, to discover, and trying to improve that diversity to tackle the problems that we currently have, that are the nutrition, climate change, and productivity.
Fantastic. And we talked a little bit earlier about innovation in scientific techniques and how important that is in other seed banks. I wondered if you had any examples to share with us of how science innovation is changing work in your institution.
Yeah, actually we also launched a new seed bank, and one of the main ideas of this seed bank is also to innovate. So we put in place our digital gene bank, and also we are implementing AI and digital tools to accelerate the assessment of that diversity and to discover faster what diversity we have, what traits that diversity have, that we can then deploy faster on the ground. So right now it's a lot on the use of artificial intelligence and digital tools to accelerate the characterization of that diversity.
How far can that go? How fast could you do this?
So how far we are, so as I was saying, with that we have this flagship project on low methane forages. So right now we are screening more than 100 accessions in our campus. And then when we identify those that seems to have these antimethanogenic compounds, we are taking these into, I'm just giving this an example on how fast we are going. So we also have these respiratory chambers where we have animals, and we are feeding them with different combination of these forages that have these antimethanogenic compounds to see what could be the optimal mix of feed to the animals that can help us to reduce methane without giving up productivity as well. So this is how we are accelerating. We could have not that done many years ago. Now we are doing it. We are screening faster, but also doing these assessments on the campus. Thanks.
Marcela, thank you. That's a very vivid example. Let me turn now, if I may, to Tech. Tech, do you have a microphone anywhere? Because so you explained to us that CIMMYT is focusing on maize and on wheat, and I think you lead on climate change science. How is climate change affecting these crops? Give it a try.
Thank you. Am I audible? It's very difficult to know whether we are audible or not.
We can't hear anything.
Yeah. Yes, I think climate change and its variability, it's affecting crop production in a multiple way. Not only maize and wheat, but all the crop and livestock system, by affecting the physiology and productivity, as our director mentioned earlier. It is not only that, but also many climate-induced disasters can also damage the crop or livestock as well. I'll try to give some example, for example. So one of the example is terminal heat in the wheat. So, for example, when we grow wheat and then in a spring wheat situation in a tropical environment, when we are about to harvest wheat during March, and if the temperature during March goes beyond a threshold limit, specifically night temperature, that will affect the grain filling period, and that will reduce the grain filling period, and that means it will also reduce the size of the grain and also result into cerebral gain, tremendously reducing the wheat yield, and that's called terminal heat, because the heat is affecting at the terminal stage of the wheat maturity. Huge loss. One terminal heat can result into 15 to 25% of the wheat yield per year. And then look at all the wheat production environment in the tropical environment, and if the terminal heat occurs, how much it would affect. We see that maize, for example, maize is also grown in the summer season, and it requires water, but it is not very good with high water. And then flooded condition during the rainy season would affect the maize due to flooding as well. Rice is water-loving crop. We all know that rice loves water. But untimely rainfall, this October, untimely rainfall at the time of rice harvest in South Asia, in India and parts of Nepal. I originally come from Nepal, so I understand all this, real figure here. So basically, the incessant rainfall that has occurred just at the time of harvesting, resulting into lodging of the crop at the time of harvest, that will result into a lot of crop damage. At the same time, the way that farmers harvest their crop is they will just either by doing machine or by manually, they will just dry their crop on the field, and due to heavy rainfall, it will just, you know, damage whole crop in the field as well. So huge loss. It is also, as our director also mentioned, that climate change and climate-induced extreme events are also creating congenial environment for many of the diseases and pests like fall armyworm or wheat rust, rice blast, for example. These are all kind of diseases that has been also associated with the climate change. So there are many examples that I can go on and on, but I'll stop here. So these are some of the examples how climate change is affecting, by affecting the physiology and production itself, by inviting unnecessary diseases and pests, and also by damaging the crop at the time at different stage of crop production.
Thank you. And can you expand a little on how seed research helps in tackling these impacts?
Yes, I think seed research or seed bank is a fundamental for tackling this impact. Number one is it gives a kind of a genetic material, the resilient and tolerant seed itself to address many of the challenges. For example, in CIMMYT, we had been developing what we call is drought-tolerant maize and stress-tolerant maize. And through these initiatives, we have developed over 100 drought-tolerant maize for 13 different countries in Africa. And this maize has reached to about 16 million farmers across Africa. And this has been one of the resilient cropping system within many initiatives within Bill and Melinda Gates and CGIAR's flagship program on climate change. We call it ACRA, Accelerating Impact of CGIAR Climate Impact in Africa. So this drought-tolerant maize that has been developed by various centers, including CIMMYT, is one of the technology that we are promoting in the African region. One example there. But as CIMMYT is one center. Ismane talked about on behalf of many centers involved in it. So this is one example. And also, if you are looking at rice, for example, rice is also suffering. One is from the heavy rainfall, another is from the drought. And there has been a lot of drought-tolerant rice varieties that has been developed, which is also coming from this seed. One is that developing those varieties itself, but conserving this seed for the long term would also mean that providing a genetic background that is needed when those kind of climatic challenges or climate-induced challenges come in future. Again, wanted to bring back the issue of fall armyworm. When fall armyworm hit the maize, then we need to find a genetic resources that is tolerant to that. And then plant breeder went to the genetic assessment that has been maintained in CIMMYT. For example, CIMMYT maintains the world's largest genetic resources for maize and wheat, and then we quickly identify those genetic resources, transport to the commercial varieties that are available in the farming condition, and quickly develop those varieties that was tolerant to fall armyworm, for example. Same is for wheat rust. Same is for fortified crop like zinc-fortified rice or zinc-fortified wheat, for example, for better nutrition. So it's not only climate, but also climate and other stresses, including nutritional security, that this gene bank would really be contributing to.
I know you. Can you hear Tech? Okay. No, we can't hear, but they can because it's going that way. Thank you. I think it's. Tech, can you talk
I
to
hope
us?
so. They are hearing.
So I think some of your work has focused on South Asia. Can you share any examples of seed-related projects in that region?
Yeah. Well, first of all, I would like to highlight what CIMMYT does, for example. If you think about all the wheat and maize grown in the world, all the maize and wheat grown in the world, so 70% of the wheat grown in the world comes from the varieties that has CIMMYT material. And 50% of the maize grown around the world also come from the varieties that has CIMMYT material in one way or other. So we maintain that genetic repository and send it to all the countries. Every year we send about more than 13,000 of seed sample all around the world for the government research organizations in more than 80 countries every year. So that is one kind of initiatives that we do in order to supply the genetic resources, not maintaining it, but also supplying it to the countries where it is really needed. And then when it comes to some of the work, for example, there are 3 ways that the seed system can help addressing these challenges. One is providing those genetic material that are ready to, and they are already conferring those tolerance. Another is providing the genetic material, again, for the national system to breed against the problem that they are encountering, for example, be it all these climatic calamities or all the diseases that have been induced by the climate, or all the food and nutritional security needs that national governments are meeting. Another thing is we are also maintaining the community seed bank, as Marcella also maintained. That's not only the seed bank that we maintain into the seed, high-tech seed bank, or in the cold ball, for example. It is also the community seed bank that we maintain in the community level as well. And then, one of the example is, for example, in Ethiopia alone, we are maintaining over 40 community seed banks of, that contains the varieties of wheat, maize, sorghum, teff, and all the varieties that are grown across Ethiopia, for example. In Nepal, I'm coming from Nepal, so I try to give, I always love to give example from Nepal. So, it's also, there are more than 100 community seed banks across Nepal in a small country like that. So that is one way for the farmers and the local community to conserve their seed and crops that are adapted to their local production condition. One is for climatic resilience. Another is to maintain their tradition and their culture over the time, because if they don't maintain their crop, they would also lose their tradition and culture over time, right? So that is also another way doing that. Oh, yeah. Okay, thank you. And another way is in situ crop conservation, for example. So seed bank is one thing, community-based seed bank is another thing, but what about conserving those seeds right on the field, in situ crop conservation? So we are also working the way to maintain those crops into the field itself, so that farmers keeps on maintaining those seeds, not for the sake of conserving, but also as a source of livelihood. So by promoting those local crops and varieties and land races, linking them with the nutrition, linking them with the culture, linking them with their medicinal value, and linking them with the resilience against all the climate variabilities is one way to maintain those genetic resources that has been grown over the generation by the farmers, that can be again used when we had this kind of climatic extremes.
Tech, thank you so very much for those fascinating tales. Can I ask you to pass that? Biren, do you have a microphone there? And I suggest you push your chair back, away from the microphone, away from the speaker. So talk to me, Biren, about the role of seed banking in Australia, and what's going on there?
Yeah, all right. So maybe setting the scene, I might talk through Australia being a mega-diverse country, over 21,000 terrestrial plant species in Australia, and we've got every biome ecosystem there, from thick rainforest to desert, and many plant species across Australia that are endemic to Australia as well. I think it's 84%. So our unique flora highlights the importance of global collaboration to bank seeds and research conservation methods to protect this plant diversity. And the MSBP, the Millennium Seed Bank Partnership, was instrumental in helping Australia, helping build Australia's seed banking capacity in our early days, from the years of 2000 to 2010. We now have a big collaboration across many of our subnational governments for this, with over 11,500 duplicate seeds collections that have gone to Kew to help us conserve and restore our plant species. And we've actually lived that experience where we've needed to do that, as Alex said earlier, with the devastating 2019-2020 bushfires that wiped out 30% of our land mass, and we needed to actually to use those stores to make the biodiversity prosper after that event. Our seed bank partners supported conservation actions for 827 fire-affected plant species across the affected regions, and that had a rapid flora assessment, seed collecting, germination trials, propagation, species translocations, and reintroductions to those areas. So 524 plant species were banked, including 72 nationally threatened species, demonstrating the impact of this work and the importance of the partnership. Q continues to support Australia to bank threatened species, and as a mega-diverse country, we're also discovering new species as we're going along, and working with our Indigenous peoples, the traditional owners of the area, to I don't know if the word discover, but to work with them to allow them to tell us about those species and what they can do with their kind of free, prior, and informed consent on our ways of working. I had a point about how many subnational banks we have. So we now have 10 conservation seed banks working around Australia to do that, to continue the safeguarding of biodiversity, which in a large part we have now really recognised the need for that after that bushfire event.
Fantastic. Thank you so much, Biren. I'm going to turn to a whole panel discussion now. And Marcella, I know you've got to leave in just a few minutes, so I'm just going to ask you one question before, sadly, you have to leave us. And that is, tell me about the future of seed banking in your region. Well, your regions and your organisation.
Yeah, I think the future I see from my personal perspective as well is, as I was saying, implementing tools that can accelerate our discovery of what is in there in those seed banks. That's the first one. The second one, and I know that I see my colleague from the New York Botanical Garden, is how we can combine better the agrobiodiversity that we are safeguarding with the diversity that they have in the botanical gardens to build more resilient systems that build on more diversity. We were discussing yesterday that I think that the agricultural seed banks cannot be in isolation of other sources of diversity anymore. Okay. We're just talking in another meeting that we are talking about climate adaptation. We need to put biological solutions at the center. So beans alone are not going to be enough. Cassava alone is going to be enough, but we need now to start connecting this different diversity to build more resilient systems. So this is where I see the future of the seed banks, and thinking more in the use and how to combine with different sources of diversity.
Fantastic. Thank you, Marcella. Marcella has to leave us. The rest of us are going to carry on with this conversation, and then I'm going to bring in and ask you for your questions. But let's thank Marcella. Thank you for your time. Thank you, Marcella. Bye-bye. So the same question for the rest of you. Tell me, what do you see in the future for these subjects about plant conservation, seed banking? What's coming next? I'm going to start with you, Ashmahani.
I think technology going to be used more in terms of gene mining and finding new criterias. But I think we have also, again, I go back to local farmers' gene banks. We don't have enough of them. And given at the rates that we are losing species, I think we need to do that. Not all of it should be, as we have it, very expensive and very beautiful. Most of them are really gorgeous, I have to say. But also maybe small local seed banks. And that could be really a movement to really get the species before they are disappearing. So I think really, and going from only plants to other species. So as CGR, we have in our article that we are protecting the plant, but we don't do for the microorganisms, we don't do it for viruses, we don't do it for bacteria. And really, I think nature, it's not only plants or animals or microorganisms, it's all together. So definitely the future, we should invest more in the protection, in the collection, and use the community-based seed bank, the low-tech seed banks as well, and combine all of it to make sure that we preserve what we have now before we lose it as well.
So can I ask a really obvious question, which is this would this technology work for all seeds? Can you just put them in a jar and keep them airtight? No.
For the seeds, I guess yes, but maybe they are more expert than me. I'm not an expert. But for many vegetatively propagated plants, for example, like the banana, the potatoes, like many other species, you can't use this. Normally we use cryopreservation for those species, or you use it in a media in tubes. And there are other species that you can do this, but maybe my colleagues knows more. I give you that.
Well,
Yeah, I think that's a good question, Angela, because people perhaps not familiar with what you're seeing here. But this is an image from our seed bank, so the Millennium seed bank, and it's basically seeds that are stored at minus 20 degrees centigrade. So you first have to dry them at 15%. So that's the normal protocol, and that we work with about 60-70% of all plant species, we think, and then. For the others, you need, cryopreservation or other techniques, if at all possible. Yeah, it's an incredible resource, and we are innovating, but it seems that it really helps us preserve them. And if I may go into the future question, at Q, we are very pleased to be celebrating 25 years, but we're even more excited about what's to come. And for the next 25 years, our thinking at the moment is three things. The first one is to prevent plant extinctions. I personally, growing up in Brazil and seeing so much of the amazing rainforests I used to play as a child disappear, we know that, it's a failure for humankind, I think, every time a species go extinct. And it's not all about the amazing properties of species for us in many different ways, but it's also a moral and ethical problem. So in a sense, what we're hearing from Sir David Attenborough, the safety insurance continues to be vital. So we have to focus our resources on the species that are most threatened. And for that, we're using AI and others. So first one, prevent plant extinctions. The second objective is rescue to restore. So we're trying to restore habitats with native plants and using these as a way of increasing the quality of those efforts. So there's so many, I'm afraid to say, poor examples of restoration efforts which are not using the right species in the right place. And I think that by using the knowledge we have about how to both store those seeds but also how to bring them back to life, how to germinate them, is absolutely crucial. And therefore, it's not only about breaking down the boundaries between agriculture, so crops and non-crops, but also between conservation and restoration seed banks and nurseries. And the third area is about nature-based solutions. Because we've been collecting seeds for decades now, it's now time to use them. So we are not only trying to measure success by how many seeds we put in a seed bank, but how many we take out and use for exploring new sources of medicines to, diseases we have no cure yet for. Or, as I said, micronutrient sources and many other properties that plants can give us. So those three areas we believe are going to be the most important moving forward. And we'll be very happy to get anyone's feedback because we are at this point in the process of designing the next strategy for Q and our partnership as well.
Fantastic, Alex. Thank you. Hold that thought, because I'm coming to audience questions in just a moment. But first of all, Tech, tell me, what do you see in what's exciting in the future in your area of work?
I think so. Basically, my area of work is climate adaptation and mitigation from the food system. But because this is event on the seed system and how seed system or seed bank would conserve on that, would play on that. So we talked a lot about climate adaptation, the role of the seed bank or seed system in adapting to resilience and climate-induced disasters, etc., etc. But it is not only adaptation, it also helps in mitigation, for example. We have not thought about, for example. So it's basically, one is crop diversification. So seed diversification is one way of crop diversification that helps growing many resource use efficient crops. Another one is transferring those genes that has been proven to be resource efficient into the commercial varieties, and that has been successful as well. So you might have heard about BNI, which is biological nitrification inhibition. So nitrification inhibition is a process of nitrogen transformation into the cropping system by which nitrogen moves from more stable form like ammoniacal form to nitrate form, which is more labile form, and that is prone to loss into the environment as emission and leaching. And nitrification inhibition is a process of slowing that process to keep nitrogen in more stable form for the longer period. That will in turn enhance the nitrogen use efficiency by the crop, meaning that crop will take nitrogen more efficiently. That will result into nitrogen lost by emission or leaching. So that's the nitrogen use efficiency. And using that biological property on those seed banks, having those biological properties in the seed bank and then transferring into the commercial variety is one way, and then that's how we have been, we are working on that. For example, biological nitrification fortified wheat, BNI wheat, and we had developed that BNI wheat by transferring the BNI properties from its wild relatives, which is Lacus racemosus, to the commercial varieties of the wheat that can be grown in Africa, Asia, Latin America, and even in Europe and America. And from the preliminary testing, it has been found that the wheat variety that has been fortified with these BNI properties can reduce the nitrogen use, which is essential nutrient for the crop production, but also culprit for the environment due to nitrous oxide emission. That can reduce nitrogen use by 8 to 21%, reducing greenhouse gas emission also by up to 21% as compared to the same wheat varieties not fortified with the BNI property. Isn't that amazing? One seed technology. And then we are testing the field scale emission reduction potential of this BNI wheat in the field trial in Asia, in many countries in Asia, in Africa, in Latin America, and also with partners in America and Europe. Also, America and Europe is not our mega environment for the CGIAR, but we are also working through partner on that. And from this preliminary result, and then we kind of did ex-ante analysis, what would be the global potential of BNI wheat to reduce the greenhouse gas emission, and we found that if the BNI wheat is adopted in all the suitable area across the global wheat program, that will reduce the nitrous oxide emission induced greenhouse gas emission, or fertilizer induced greenhouse gas emission, by about 15 million ton of CO2 equivalent per year. And that will also reduce nitrogen consumption in wheat production only globally by in the tune of 2 million ton of nitrogen fertilizer without compromising yield. It will even enhance the yield. Isn't that fantastic technology from one single seed technology?
That might be the best news I've heard all day. Thank you, Tech, for bringing some lively optimism to our discussion. Biren, I'm going to turn to the last question that I'm going to ask everybody, but you get to go first. So, as you know, funding's always tight. Give me the one-sentence pitch for seed banking.
One sentence. Well, this comes at a good time because this isn't one sentence. I'm sorry. The Australian government has just made a commitment for invested $5.7 million to support our upgrades to our national seed bank at the Australian National Botanical Gardens. I've lost the question, trying to get that point.
Is that the question?
No, my question is, tell me, give me a pitch for yet more money for seed banking.
Yeah. And seed banks are a good safety net to prevent extinctions, especially for species that are endemic to the areas.
Fantastic, thank you. Tech, same question for you.
Yeah, very difficult to pitch in one sentence, but maintaining this kind of seed bank is we are doing in Summit, also in Norwegian seed vault. It costs a lot. So funding requirement for seed bank maintenance, also in situ crop conservation by growing into farmers field is a huge endeavor that is very necessary, but it costs a lot. And then global research and philanthropy communities should really value the importance of seed bank and how to fund for this kind of research going forward.
Fantastic, thank you. Alex, your turn.
Sure. Okay, I'll put my hand on my heart and really say that I believe that seed banks are the most powerful and effective ways to harness the power of nature to tackle the triple crisis of biodiversity loss, climate change, and food insecurity.
Very clear, thank you. Ishmani,
I fully agree. I think it is called the bank because it has jewels, it has treasures in it. And really we need, if we don't see it, it doesn't mean it's not a treasure. It's really a treasure that we need not only to protect, we need to bring more species to be protected, and we need to use it, and we need to discover it. So we don't know what we have, but it is a real bank and much more important than the money that we print ourselves, and we call it money, and we are working and sweating for it.
Thank you all four of you. Those were great answers. So I've hogged the microphone asking questions, and now it's your turn. So if you have a question for any particular of our four speakers or in general, fantastic. Put your hand up and we'll see if we can make this work.
Thank you very much. So I'm Sam, and I represent a UK-based climate tech company called A Healthier Earth. The past 4 years, we have been trialling the application of vertical farming technology to the production of high-quality, climate-resilient forestry stock, the production of saplings. And I couldn't agree more. The seed banks are an incredible asset that we need to start deploying, and to do so now. But what I'd like to do is get your perspectives on a question that I get asked a lot, and a question that I really hate being asked. And it's this: how do we deploy the assets of seed banks responsibly? And by that I mean, how do we ensure that we maintain biodiversity and without encroaching upon nature, but while delivering the outcomes that the seed banks have been set up to create?
Great question, Sam. Thank you. Who'd like to volunteer to go first? Tech.
Yeah, I think I would like to talk about the in situ crop conservation on this. So in situ crop conservation is another way of conserving, maintaining, and using for the longer duration in situ in the farmer's field, so they can use it, for example. So, and there has been very much successful example across the global south. I believe it is also in the global north. I don't have a lot of experience from the global north, but if you look at Asia, Latin America, or Africa, so maintaining those seeds, varieties of the seed for cropping system diversification, and it's not only cropping system diversification, it is also their cultural diversification, their religious diversification, and growing that and using those crops as a generations of tradition. And a person coming from Nepal, I have seen that. I come from the farming family. We have seen, we used to grow, like hundreds of different crops in our field, for example, in a parcel of land across the homestead, for example. That is part of the livelihood that we grew up with. So when you need spices, for example, you grow that in your field. When you need chicken, you have those chickens in the field, for example, roaming around. When you need a fish, you have a small fish pond just around your homestead, for example. So it's not only the commercial crop of rice, wheat, maize, soybean. It is also about all sort of crop, vegetables, fruits, spices and livestock species, aquatic species, name it. And they can be grown, used, and add value to that, and keep on recycling under generation. So in situ crop conservation, I would say.
Thank you, Tech. Alex, did you want to address this question too?
Yeah, so I just want to be a little controversial here because, so, you know, you get some debate. But I think a lot of the discussions are around improving traditional crops. And, you know, just as I said, for hundreds of thousands of years, we've been relying on so many different varieties and species of plants for our survival. But during the Green Revolution, we had this total shift from going from many plants to few plants. And the fact that now more than 40% of all calories come from just 3 species, so wheat, maize, and rice. So nothing against them. I like rice, you know, I eat bread, but, you know, it just makes us incredibly vulnerable, I think, in the face of climate change. And we know from our work at Kew that there are more than 7,000 different plant species that are used locally as crops. So I do think, you know, back to what you said, that diversifying our food systems will be an important, not the only, but an important contribution to both, you know, protecting nature and using it. And agroforestry, for instance, are systems where you have an incredibly diverse of birds and other plants as well. The problem might be scalability. So, you know, if what you're looking at is just increasing yield and optimal conditions, you may not get that. But it generates more jobs. It creates that kind of heterogeneity where biodiversity can thrive. So I think that we have to diversify our food systems, and I think the collaboration between agricultural and more traditional banks, seed banks, are going to be very important for that as well.
And maybe just to add, in situ conservation, we used to do it ourselves, particularly for trees, but it's so costly. It's very costly, but that's the best way to do it. Right now we are doing mostly ex situ like this, but we're not doing it in ecosystem, and we should bring it back sincerely. When I was in AgriZone, I went to the Imbrapa station, and there they have what they call secondary forest. So it's a forest that has been cut, but then they let it come back for the last 80 years. And it's amazing. If you have time, go and see it. When you give time to nature, nature get the balance in. They didn't plant one single tree. Everything was natural. It was just protecting it. So we need to do more of that. So there is a bit of a target that we are not able to get, but that's very important. And maybe the last idea on diversification, I couldn't agree more. We are really, not only we are using only few species, but within the species, we are also having narrow genetic base. So we should be intentional about diversification in terms of the number of species that we use, and within the intra-species genetic variation as well.
Fantastic. Are there any more questions for this wonderful panel? Remind us, tell us who you are as well before you ask a question.
Hello, everyone. My name's Soleil. I'm from the Cayman Islands, so I'm no stranger to endangered species whatsoever. And I know you mentioned earlier about needing young people to be involved, needing young people to care about seed banking. And my question is, what is the best way for young people to get more involved in this? What sort of things should you be studying? Should you be learning about to kind of get into a space like this? Thank you.
Thank you so much for the question. And it's great to see young people here engaged and asking questions. So it starts with education, definitely. So be it interested in nature, but also in understanding nature. So as somebody that works in few universities, it's very hard to attract people to the subject of biodiversity or even agriculture, as a matter of fact. So I think really we need to bring more awareness and get you as you to be passionate about it and maybe interact with nature. I mean, I'm glad to see that you are from an island and you are interested in it. My kids are interested in it because I take them out, but many of my friends hardly know what a wildlife is. So we need really to bring ourselves and our kids and the Generation Z and the next generation back to be interacting more with nature. And one of the area in terms of studying it right now, those areas of biodiversity or even agriculture are not paid enough. So that makes it that most of our kids are looking to be doctors or lawyers, but not so much biologists. So maybe there is a need really to completely look at the value and bring it the right value if we want to really get you guys to be interested in it.
Just practically, we can swap contacts, but we have a queue, many volunteers and internships, and we work a lot with the UK overseas territories as well. So the range of programs, we have New York Botanic Gardens here, we have many organizations which are doing interesting things if you're interested in plants. So yeah, I think just reach out, never be afraid, and I think it's really wonderful for us to have young people showing interest, and if we can help. But I think just my advice is also to learn about plants, and you can use mobile apps like Our Naturalist. You can take photos, you can start learning about the flora you have around yourself in the Cayman Islands. So I think just getting a bit of sense for which species you have around you and which of them are threatened could be a good starting point as well.
Yeah, I can add very briefly. I can't agree more on what Asman and Alex said, for example, having more interest in biology. But as youngsters are having more interest on technology, AI, and modeling and all sorts of things, and you can also think of, for example, harnessing the capability of AI modeling and analytics to see the societal benefit of analyzing all these access and what kind of benefit in terms of food security, climate adaptation, climate mitigation, nutritional security that this seed technology can bring to the society, for example. So that's where youngsters can also play a role if they are not biologists, but also very good at technology, for example, or AI, something like that.
Yeah, thank you. It's interesting because as I was growing up, we were seeing a big focus on young people to learn about computers, and computers are the future. And I think now there's recognition that computers and smartphones are good, but it's kind of comes a point where it becomes unhealthy, right? In Australia, a lot of schools are now doing classes where they're learning out in nature and connecting with nature, the relationship that nature has with humans and vice versa. And I think that's a good shift that we're seeing. And there's other impacts like mental health impacts, and we're starting to see children like less anxiety and other kind of improvements like that. With Australia, we also have our National Science Agency have school-based traineeships, so students that are in high school or at university can go and connect into those into our National Science Agency and learn more about the work that they do and kind of how at least the government interacts with nature and more about how it works. And yeah, thank you.
Fantastic. I have time for one last question, if there is one. Yeah.
Thank you. This is fascinating. My name is Haruhiko. I'm from Japan. The question is, you talked about need for finance. I think she was talking about careers. I guess if I may, the question is about revenue coming from seed banks. For example, does Australia, when they're provided with seeds from the seed bank, does Australia pay, maybe not much, but a little bit to the seed bank? Or if there's an improvement based on the new maize or wheat species developed by the seed bank or the researchers around it, do you get some kind of revenue flowing through your institution? Thank you.
I could start there if you want.
Yeah,
so we are only allowed to use the seeds depending on what the source countries have given us permission for. So the only reason why we could send this species back is because Australia itself had allowed us to do that. So there's a lot of restrictions around what you can use the seeds for. Most of the cases are non-commercial uses. I think there's a bit of an interest from the government for us to use resources such as seed banks to generate income and jobs. But I think at this moment, I'm not aware of any charging economically to any such efforts, because we're trying to contribute to the common good. But perhaps moving forward, there might be opportunities for seed banks to help in restoration projects which are funded through biodiversity credits or other more corporate relationships which then could require funding, and that could also be feeding back into the seed bank. So I think we do need a bit of innovation in the funding mechanisms, because as we're talking here, I've been to seed banks which really make me sad, and I think funding is a crucial and really urgent issue to tackle, because a lot of those small seed banks that you said are very important, they're just collapsing basically because they don't have any funds. So I think there's some good opportunities there.
Yeah, shortly, I think my answer is also on the same line. So we are publicly funded research organization. So any product coming out of the research and all the seed product that we maintain, distribute across the globe, it has to go free of charge. We don't charge a single penny to send that. Every year, as I said, we send over 13,000 seed samples all across the world, one center. So we'll talk about whole 16 center. So we send this to 80 countries from one center. We don't charge a single penny for that. So we don't charge.
Yeah, exactly the same. So it's a public good. And that's why government support is very much needed. Otherwise, it's going to be only for the elite, and that's what we don't want. So it's public good. There are other ways of generating maybe revenues, but in general, it's a public good. Yeah.
Just wanted to add one more thing. We still give those genetic material to the public, private companies as well, with free of cost, so that those seeds keeps on multiplying and getting to the farmer's field.
Fantastic. Thank you for these 3 great questions. I'm really sorry, but we're out of time, and I'm going to wrap this up. So I'm not going to make you sing happy birthday, but it's great to be here today to celebrate the 25th birthday of the Millennium Seed Bank. And I think it was fantastic to hear so many hopeful messages. He's looking very well for 25. But I hope, like me, you come away from this panel with a lot of hope, actually, that there are things we can do, and that there are things that we can do together, and that there are things that we can continue to deliver as public goods in order to make this jewel store, and it is a jewel store, isn't it, that is such an important protection for all our futures, particularly in this world where we know so much is changing so fast. So please join me in thanking our panel and yourselves for being such a great panel and such a good audience.